Welcome to A-Levels Computer Science, and we are on paper 3, 9618, and the component is 3-2, chapter number 15, hardware. We already know that computer is a perfect combination of two things. What are that two things? The two things are hardware and software. What do you think? Am I right?
Yeah.
Yes, computer is a great combination of two things, hardware and software. So we have started a topic of hardware, and you say, okay, sir, it's a very common topic, like in A levels. Why we are studying it? Basically, we are not going to study here like hardware, types of hardware, monitor, keyboard, mouse. No, we are going to discuss the depth of hardware, like in CPU, what we have, like we have processors. So what are the types of processors, how they work, what are the things we are connected with. So in this chapter, we are going to do all these things. So our first topic is processors. Two types of processors are there. How many? Two. So first, can you tell me what is processor?
It's like the main thing that computes and does everything for the computer. It's like the main operating system
Yes,
where
which manipulates or control the entire computing. What do you think?
yep.
Processor. Processor is just like our brain, just like the human brain. We have a processor. Okay, now here we have two types of processors. There are two types of processors. Number one, RISC, and number two, CISC, right? These are the two types of processors. So we are discussing one by one of both types. First, let's start. Early computers made use of the von Neumann architecture. Do you remember the von Neumann architecture?
Yeah, I do.
Can
We
you
did this in A levels too.
Yes. Can you tell me what is the basic concept of von Neumann architecture?
It was basically like a structure where basically it went through like we have MAR, we had MDR, CIR, and
Yes.
stuff.
So MAR, MDR, PC, CIR, these are all what? Registers. So the von Neumann
Registers.
concept is a computer with memory, right? So von Neumann works on the concept of what? On the concept of a memory. A computer comes with a memory. Do you remember?
Yeah, I know.
PC, CIR, ALU, MU, these are all the types of registers. So this is the concept. Now, modern advances in computer technology have led to much more complex processor design. We all know this thing that as the time is passing on, the computers are become more advanced. The computers are become more advanced. Acha, maybe the computers are getting more complicated. Like maybe it is easy for me, but maybe the computer is complicated for others. So it must be some good points and some bad points. What do you think? Like if you say the AI, if you say the AI is going to control many things, even if you wanted to solve any of your topic, if you wanted to make an assignment, you can use the AI, you can use a chat GTP, you can use other features. So the things are getting very easy for the students, but it is going to minimize the research process. Like now you guys are not going to research on the topic. Why? Because you think, oh, who's going to waste time? Let's open chat GTP, write down the objective, get the answer, paste it in the notebook, and we have done. And you know, this becomes the biggest loss of the programming field. The people are getting more jobless. Why? Because the companies are just firing the programmers because they have now they have the chat GTP and the many other AI features to make the biggest complex programs in a seconds. So they think, why should I hire the programmers? We are giving them the millions of rupees as a salary. So there is no point. So look, the things are become easier for some people and become complex for the some people. Did you get it?
Yep.
So the two basic philosophies have emerged over last few years. Number one, developers who want the emphasis to be on the hardware use. The hardware should be chosen to suit the high-level language development. And the developers who want the emphasis to be on the software set to be used. The philosophy is driven by even faster execution times. So nowadays, the things are getting different. 2 points are there. The 2 philosophies are there. The 2 researches are there. One, the developers have to work on hardware, and the developers have to work on the softwares.
Software.
Right? You come to know that GTA 6 is coming in the market.
Yeah. The newest, I think, OpenAI language, was it?
Yes.
Like,
and you know, GTA 6, I go to the computer shop, I ask for the GTA 6 recommendation PCs. The person told me that you have to make a new gaming computer because you're not going to use the previous one. So you need to upgrade your processor, the RAM, and the storage. I said, why? He said, because the game supports some new things. So you have to upgrade your computer according to the requirement of the game. Otherwise, you are not able to play the game. So look, for the latest software, I need to upgrade my hardware. Did you get my point?
yeah.
Like you are using PS4 and you wanted to play GTA 6 on it. No, you can't. You have to upgrade to PlayStation 5. Are you getting it? And if you are playing on a PC, you need to upgrade your PC hardware. So after that, you are able to play that software. Game is a software, right? Game is a type of a software. So this is how the point is. This is my point, that the computer is going to be complex in a form of this way, that we need to upgrade the hardware for using the latest softwares, or vice versa. Is that okay?
Okay. Yeah.
So the first philosophy is a part of a group of processors architectures known as CISC, complex instruction set computer. And the second philosophy is a part of a group of processor architectures known as RISC, reduced instruction set processors. I hope it's very clear in your mind.
Yeah, it's clear.
So it means we have 2 processors, RISC and CISC. CISC means complex instruction set computer. RISC means reduced instruction set computers. So this is how the 2 philosophies are going to be implemented in the last few years. And yes, it is implemented in the market. Like I am using MacBook Pro. I wanted to switch. Achha, I'm not using M1 processor chip. So the new processor chip is M1 in MacBook. I think you know about it. So I need to switch from my old Mac to my new Mac because I wanted to use M1 processor. So look, the hardware is upgraded. It's costly. It's very costly. But if you wanted to upgrade, you need to take that thing. You need to pay the cost. So let's start with the CISC. CISC means complex processors, right? Okay, first what you have to do, whatever I have explained you need to take out your notebook, write down some notes on it. Then I'm going to start with the CISC processor, okay?
All right, okay.
SIC processors architecture make use of more internal instruction format than RISC. Yes, we already get a concept of this, that they are complex. Complex means, of course, they are upgraded. They are much difficult, right? So the design philosophy is to carry out a given task with as few lines of assembly code as possible. So CISC processors are going to do the task with the assembly codes as well. So if the instruction set is based on assembly code, CISC processors works with it. So the processor hardware must therefore be capable of handling more complex assembly code instructions. Remember, in the ES levels, we have done some questions related to assembly codes.
Yeah, I know. We had an entire chapter on it.
Yes. And in that chapter, we come to know how to implement assembly codes like LDA, ADD, STO. And I think there is a whole chart of assembly codes. And there is a log. We need to read the log and then we are going to solve the question. So related to that topic, we use the assembly codes. We use the computer, the CISC processor use assembly codes. More complex assembly codes is dealt by CISC processors. Okay, for example, suppose we wish to add two numbers A and B together. We could write the following assembly instruction like this. So add AB. This is a single instruction that requires several sub-instructions, multi-cycle, to carry out the addition operation. So this methodology leads to the shorter coding than RISC. And this, but may actually lead to more working being carried out by the processor. Yes, they are complex, they are a bit shorter, and they are a bit faster than RISC. So this is how the CISC processor works. They are shorter, they are using the assembly codes, and they are, I think they're much quicker than RISC, right?
Yeah.
Let's discuss about RISC processors. RISC processors have fewer built-in instruction formats than CISC. Fewer means they are short of the instructions. So CISC processors have the more assembly code instructions, and the RISC have fewer. Did you get it?
Yeah, okay.
So this can lead to higher processor performance. The RISC design philosophy is to build on the use of less complex instruction, which is done by breaking up the assembly code instructions into a number of simpler single cycle instructions. Yes. So RISC, they are not complex. They are easy to understand by the processor. Why? Because they are going to break the assembly code into the simpler instructions. So if anything is going to perform the job by breaking the job, remember the top-down design, the structure design, the breaking down of a system into a small task. So the RISC processor works on the same thing. They're going to break the assembly codes, the complicated assembly codes, into a small codes, into a small instructions. And that is the reason they work faster. Ultimately, this means there is a smaller but more optimized set of instructions than CIS. So which one is faster?
So of course, I guess it's gonna be the CIS since it's gonna be more optimized.
RISC.
Or will it?
RISC, because they break the assembly codes instruction into the small single instructions, and that make it more faster. Now let's see an example. Using the same example as I have to carry out the addition of two numbers, A and B. So this is an equivalent operation to add AB. Remember this instruction of CISC, right? It is just a single code, right? Okay. Now you see here, load X, comma A. So this loads a value of A into the register X. So look, it is going to make a register as a variable, look, X, and it is going to store the value of A. So if the A value is 5, so it is stored in X. Now load YB. This loads a value of B in the register Y. Now you have a next register Y, In a Y, you're going to store the value of B. Let's suppose the value of B is 2. Now, add A comma B. This takes the value of A and B from X and Y and adds them. So if you're going to add them, so the X and Y are going to take the value, that is 5 plus 2, it becomes 7. And this 7 is going to be added into the register, yes, Z. So X plus Y is equals to Z. So in Z, the value of 7 will be stored. So it is a bit tricky and lengthy, but the convenient way. So both processors are working same, but the way of working, the way of processing is different. RISC breaking the codes into the small instructions, like you see here. It takes X, it takes Y, and it takes Z as a register in order to save the instructions, isn't it? Is it okay?
Not bad.
So is there any problem?
No, I get it.
Okay, now what you have to do, you need to write down the CISC processor and the RISC processor along with the examples I have teach you. I'm going to share you the screen first for the CISC. Once you finish, let me know. I will move you to the next.
Okay.
Let's see. So we have some features of CISC and RISC. Number one, many instructions formats are possible. Yes, we know the CISC deals with the complex programming or the assembly code, so they can deal with the many formats. Number two, there are more addressing modes. Yes, if they are using the assembly codes, the complex codes, so definitely they have the more addressing mode. The addressing mode topic, I think we have done in AS levels. Addressing modes. Number third, make use of multi-cycle instruction. Multi-cycle instructions means several instructions works in a cycle. The multiple cycles works with the multiple instructions. Number four, instructions can be of a variable length. It means the length of instruction, maybe it is complex, it is in detail, or maybe it is short. Now, let's see some features of RISC. Number one, use fewer instructions format sets. So in the start of the RISC processors, I told you they work on the fewer instructions, right?
Yep.
Number two, uses fewer addressing modes. So we have, I think, 4 to 5 addressing modes, and they are using few of them. Number third, make use of single cycle. Yes, it is not going to use multiple cycles. It is going to use a single cycle and break the assembly code into the small set of instructions. Remember, here you see. Instructions are of a fixed length, as it is going to break the instructions assembly codes. So they're going to break the codes into a fixed length, and then it is going to interpret our data. So these are some major differences, and rest of the differences you have to go through in your homework, right? This is your homework.
Okay.
Now we are going to start a new topic of pipelining. What is the meaning of pipelining? What do you think? Any idea? If I said,
I think is it like a function that
yes, one
like
after
since
you can say the instructions are going to be done in a one after another, or there's a sequence of instructions. So let's see. One of the major developments resulting from RISC architecture is pipelining. So here in RISC, what you have learned, that RISC is going to break the complex code into a small piece of code, right? So if the code is breaking down into a small piece, definitely we are going to send the code one after another. So this one after another comes in the topic of pipelining.
Okay.
Right. Okay, so this is one of the less complex way of improving computer performance. Okay, as the time is passing, we are moving to a much complex computing. We need at least, even in a cell phone, if somebody offers you 4 GB RAM, what do you think? Are you accepting that 4 GB RAM? Maybe not. Because you said, sir, 4 GB RAM, I don't think so is good. At least I need 6 GB of RAM. What do you think?
Nowadays, I guess you could say.
Exactly. Even if I'm going to buy a new phone in the market, I will look for 8 GB of RAM. How much? 8 GB of RAM. Where? In my cell phone. I'm not talking about my laptop. In my MacBook, I have 16 GB. And believe me, I'm going to look to upgrade my RAM to 32 GB. Why? What is the reason behind it? Any idea?
When you're doing multiple tasks at once, like, and for example, you could say then more of your space is used at one
Complex
time. So
that
yeah.
I'm doing the multitasking right now. I'm using Microsoft Word. I'm using Zoom. There's an Acrobat Reader open in my laptop. Two browsers are working together, Opera and Safari. And I have many applications which